Good morning. No, I don't have the Rona. Massive anxiety attack this morning. So, I like the idea of doing these little blurbs while I'm driving. Because otherwise I'll just be sitting here listening to music. So, seeing as my time is very, very slim pickings, I might as well efficiently make use of all the time I've got. So, rather than listening to music, I can do little rants. We'll call this one, let's talk about RF. So, probably one of the other big mysteries that a lot of people have run into with running a Wisp is their RF environment, which can be a hellish nightmare if you're not crafty about it. So, many companies have come up with clever ways of dealing with RF. When you're dealing with, like, mid to high-end commercial telecom, you're dealing with stuff that uses GPS sync modules so that you can time everything at the site the same. This will ensure that basically everything there is just utilizing the same channel spaces, transmitting and receiving at the same time, so it doesn't step on everything else that's co-located there. You kind of get a bit of a breathing type scenario, going back to my whole, wireless networks are organic. So what you end up getting is that as you load the tower, of course, the amount of range decreases a little bit because the power is, of course, being consumed, and the devices are all affected differently, different modulations based on different throughput, based on, you got a weak connection, that's going to cause the radio to change the modulation, push it a little bit of power. Things could operate very, very dynamically on an AP or base station. So, and that's pretty standard across the board. Now, when you start looking at premium Wisp products like Cambium, so the way that works is all the radios tie into it, and you can actually enable external sync, and you can synchronize all of your radios so that they'll transmit and receive at the same time, which then reduces the amount of co-location issues. There's now less struggle for spectrum because you're reusing a lot more spectrum. Now, that's Cambium. Ubiquiti, which many of you people are using, it's not the worst product on the planet, but there's definitely a lot better out there. Ubiquiti has its own type of GPS sync. You can actually set your timing offsets and enable GPS, and you can then channel share with radios that cannot see each other. So the trick that we use here is AB, AB, or ABC, ABC, or ABCD, ABCD, which is where each radio that's perpendicular or whatever, basically any radio that's back to back can share a channel. So you can say, when we say AB or ABC or ABCD, we're referring to a channel number or a set number, I guess you could say. It's because we're taking two radios that are back to back. A very common configuration is 490-degree sectors, or in a lot of cases horns, which are still considered sectoral type antennas, and they are back to back. So you'd have your north and south sector on the same channel, and then east and west on another channel that's guarded. I usually try to guard them by about 10 megahertz, and a lot of sites that we operate at 40 megahertz because we're pushing high throughput to our clients. And you can argue that to death, but you know what? We have to evolve, and we have to make sure that we can actually start delivering real speeds, not just these piddly shit little, 1 meg, 3 meg, 5 meg. No. Technology needs to evolve, and we need more throughput than that now. So you guys need to start selling like 15, 20, 50, 100 meg packages to your clients. Otherwise, not only are you not going to survive, but people aren't going to be able to live the digital lifestyle that they're all becoming accustomed to. So adapt. So anyway, when you're doing like an AB configuration, which is 490 degree sectors, north and south are on one channel, east and west are on the other channel. Now, when you enable GPS sync and set your timing offset, that will make sure that those two radios transmit and receive at exactly the same time. Because they cannot see each other, there's less chance of interference. So it's really a hacky way of co-locating. It's not as managed or intelligent as the other methodologies where you have a GPS sync module and all your equipment tied into it. So if you're running a Ubiquiti network, you need to be a little clever about things. So, which, that's what Wisps do. We adapt. We're the guerrilla warfare militants of the telecommunications industry, you know? Just like, yeah, we gotta make it work. We gotta make it work. I found a fucking coffee can. Can we use this as a point-to-point? Hells yeah, we can. Nah, we're not that bad anymore. But anyway, I digress. So now let's look at channel space. I've just explained the AB, which many of you guys have heard. Channel spacing. I'm in Kazakhstan, which we share a very similar channel space to US, Argentina. I think most parts of the world have very similar channel spacing as we do. But typically what I like to do is, for us here, the upper uni band. Hold on one second.
Hello?
Hey, buddy.
Hey, how's it going?
Not too bad. I'm just on my way to site.
Oh shit, you already left. Fuck, okay. I'm still in bed. I'm drinking my second coffee and I had my poop and all that over.
Yeah, no worries. So, let's see here. I was starting to get on to how to utilize your spectrum. We only have a finite amount of spectrum, and many of us operate within the unlicensed bands. So like 2.4 and 5 gig, 24, 11, in some places 18 and 36, you know. But the trick is, and what I'm going to be referring to here is, we're talking about using unlicensed first. So 5 gigahertz, as you're probably already aware, has very minor penetration capabilities, so it doesn't cut through trees as well as 2.4. So in some areas we use 2.4. 900 is still far superior to, for non-line of sight, you know, canopy penetration, but there's not a lot of 900 channel space available, and nobody's really improved on the tech yet. I mean, like, you can buy the cheap shit, which would be the Ubiquiti 900 stuff, which they haven't bothered fucking improving in the last decade. So, I mean, like, you can't co-locate 900 with Ubiquiti. It's impossible. If you're going to have a 900 sector on your tower, you're going to have a 900 sector for like a mile around. Otherwise, you know, it's going to destroy the any clients connected to a neighboring sector. The Cambium has their 900 series, which has the same type of capacity, but they of course have GPS syncs, so you can throw a few 900 sectors on your tower. Alright? So going back to 5 gigahertz here, with point-to-points, I like to reserve the upper and lower unibands. In some areas, the lower unibands only available for point-to-multipoint, by the way, so keep that in mind. But you can use 5745 to 5825, which is non-DFS channel space that has a higher power broadcast allowance, so you can actually transmit at a higher power output in that channel range. The middle bands, so that would be 5730 all the way down to 5265. That's all reserved DFS space, and that's, well, because it's also not only a lower power range that you can operate in, but you've also got the 5400 range for military radar and the 5600 range for weather radar, and I've seen a lot of dumb people operating in 5600 here in Canada, and they end up showing up on the weather radar. Ha! Good on ya. So, you want to kind of keep your point-to-point links in, you know, a stable area. Things that aren't going to be forced jump channels because of a radar hit. So try to keep your point-to-points in 5745 to 5825, and that's actually like, that's a pretty good chunk of spectrum for point-to-point links in 5 gigahertz. So I mean, like, go ahead, operate there. That's awesome. I try to keep my sectors within the DFS range. And yeah, I get the idea. It's kind of a double-edged sword. You operate your point-to-multipoint within DFS, and you're going to end up, if there's a radar hit, it's going to jump channels, right? Which you might actually have a momentary disconnect for your customers. If that's the case, you need to move to a different chunk of spectrum within the DFS band, or just drop straight down to the lower uni band to remedy that issue, permanently. But that doesn't happen too often. Usually if you're getting radar hits and you're not around 54 or 56, it's usually reflections coming from like a nearby silo or water tower or steel structure. You get like basically your radio signal will hit that, it'll just mangle it and then throw it right back at your sector, and then you're going to be seeing false hits, and these false hits will cause you to jump channels. So, and sometimes, and if you're very, very unlucky, your radar will sit there, or your radio will sit there, and it'll time down, saying, oh, I gotta wait until I don't see another radar pulse before I can come back online. And then you're offline for a short period of time. But with DFS, the functionality of it is it'll just jump channels. So you could be on, as an example, 5380, and all of a sudden, bam, you get a radar hit. It's just going to jump to another DFS channel, so it'll just jump to a random spot on the spectrum where it sees that there's no, or the lowest amount of noise, basically somewhere that there's a clean channel, and it'll ride that out for a long time. That's typically what DFS does, so it means that you're not necessarily out, but I've seen it work differently on different radios. With some radios, it's like an instantaneous change. With some radios and some firmwares, Ubiquiti, it'll actually time out and wait. So nobody's really kind of standardized that, which is kind of a nuisance. So, yeah, you pick away at what you want for my little rant here anyway. So, that's kind of how you use Spectrum efficiently. Now, the other thing as well that you can do to clean up your Spectrum, because remember, it's not just about you, it's about your neighbors. And even if you fucking hate each other, you guys need to get along for the sake of your clients. Don't take personal vendettas out on your fucking clients. Don't be like that. If you've got neighbors and your neighboring company is like shitting all over you by screwing up your Spectrum, talk to them. Be like, look guys, can we not reason about this? Alright? Make peace. Try to coordinate your channel planning, Just don't, it's as simple as this. Company A and Company B, if you see a busy channel, don't go on it. It's not that complicated, and if it's very busy, try to go on a channel that you know that you're using, but that's not in the same direction as the antenna that you're using. So you can kind of recycle Spectrum that way too. It's another way to work, right? But getting to the other option is licensed band, or higher frequency millimeter wave unlicensed band. So many Wisps broke. It's just, you're not alone. If you're a Wisp, chances are you don't make a ton of money unless you're a certain couple of people in the industry, money people, that have like millions of clients and dollars. So the Airfiber 24s and the Mimosa B24s are a great solution. Looking at them, the Mimosas and the Ubiquiti ones, they kind of each have their own benefits and drawbacks. So looking at the Mimosa B24s, they don't have range like the Ubiquiti do. And people can argue that with me to death, but I don't fucking care. I've seen the performance, alright? But the benefit of the Mimosa is that it's not locked at a fixed duty. So you can actually change your upload to download ratio and really, really scream across one of those links. So instead of being stuck at 750 by 750, you can do like 1 gig by like 200 megs as an example. Just as an example. So this way you can actually, here we go, passing a vehicle. This way you can get a ton of more throughput on a beat there on a 24 gigahertz link, and connect up your towers without having to worry about dirtying your Spectrum by using up like 200 megahertz chunk. And you know that your backhaul is going to work better. The Mimosa B24s, you can do them in about a mile. I've seen people stretch them further than that, aka about 3 kilometers. They'll do it. The Air Fiber 24s, however, are quite a bit better on distance. And yes, they both suffer rain fade, but we'll get into that in a minute, I guess. You know, I think I've still got another 20 minutes I can puke information on you. So we're looking at the 24 gigahertz range. Depending on the transmit power of the radios and depending on the type of antennas that they're using, they can go far. Now, I'm going to refer to the Air Fiber 24 now because I have tons more experience with those guys inside and out than I do with the Mimosas. So, with the Ubiquiti Air Fiber 24, the fallback, like the drawback to it is this fixed duty. You get 750 megs up, 750 megs down. You can't change the duty cycle. You can't increase the amount of downloads you've got. So that kind of sucks, but they just fucking work. They really do. And I'm in Ontario, Canada, in a K-zone, K-rain zone. So we get like torrential rain. I've noticed that links that are 2 kilometers or less, they'll put up with the worst bullshit you can throw at them and not go down. 3 kilometers, when you get those monsoon type storms, it's going to knock you down. So you want to make sure that you've got like an 11 gig failover or, you know, a 5 gig failover or just something. Just make sure you're running OSPF, right? Let's see here. Distance-wise, I've ran Air Fiber 24s at 6 kilometers and still had pretty much full modulation. Mind you, those are guaranteed to go down if you get a thunderstorm. So that's where you need your failover, okay? Moving up on the food chain here, you're getting into the more expensive gear of the Air Fiber 24 HD, which realistically, with what Ciclu and Bridgewave have available now, is kind of not worth it anymore. Because the links are extremely expensive, and you don't really get the potential capacity that you could. So, come on, buddy, move your ass. There we go. So the Air Fiber 24 HD is a different animal. Well, yet again, I would say that's literally twice the animal of the Air Fiber 24 Classic. So, with the Air Fiber 24 HD, that guy is capable of I think it claims it's around 2 gigs. Go look it up. I think it's like 1 gig either direction in a perfect scenario. And that's like a 3 kilometer link. Those guys will put up with a lot more bullshit. They won't completely die, even at 6 kilometers in heavy rain. They'll stick it out through most of that, you know, nightmare. And just some real world situations that I've seen those guys operate in. The furthest that I've pushed an Air Fiber 24 link is 13 kilometers, 12 kilometers, 12.6-ish for Air Fiber 24 HD. And with the Air Fiber 24 HD, I was able to attain 500 by 500 on that particular link. And even ice storms or heavy downpours, it wouldn't completely go out. It would drop down to CISO, but it would still pass like 100 megs or so. It really struggled. But that's at like 12.6 kilometers that it survived those conditions. So that's a testament to what they're capable of in a K-rain zone. Yeah, so they're pretty decent. But like I said, that's unlicensed band, and for the price of a set of Air Fiber 24 HDs, you may as well look at a better option, and like Ciclu, for example. Or if you can actually afford getting a license, talk to a company like Streakwave or MBSI Wave, and you know, talk to them about frequency coordination and see if you can get a license for, you know, 80 gigahertz. Because, you know, like, if you need the capacity, the price difference in going up to a higher end radio, like, you know, the Bridgewaves or Ciclus, is realistically, in the grander scheme of things, it's not that much more. And you're getting like so much more. So your cost effectiveness has just skyrocketed by moving to a better product and spending nearly the same amount of money. So, something to consider. 11 gigahertz, you need a license for in Canada. You need a license for it in the States. It performs. It'll put up with a lot more bullshit than the 24 gigahertz stuff will. Of course, it's still slightly susceptible to heavy rains. You'll see those links dip when it gets really bad. But it's a hell of a lot better. You can get more range. It's kind of like a hybrid between 5 gig and 24 gig, you know? It's actually kind of in the middle. So, you know, you can get the throughput and you have the stability and reliability with the 11 gigahertz stuff. So that's something else to consider. It also goes a hell of a distance. So I mean, like, that's really cool, especially if you've got filthy, nasty spectrum. I think that's that. Dropping back to the 5 gigahertz stuff for a second, by the way, I am a massive fan of the 5X HDs by Ubiquiti. Those guys there with a good antenna, like ALG comm, radio waves, RF elements, you know, you put a good antenna on those guys and they'll fucking chooch. With the shitty Ubiquiti 34 dB antennas, we've managed to push an AirFiber 24 HD link as far as 26 kilometers and still get 800 by 200 out of the link. That's pretty good, especially when you're shooting over about 2 kilometers worth of lake. They're awesome radios. I mean, like, they get a hell of a lot of throughput. And when they first came out, I was skeptical. I'm like, holy shit, you want to use 100 megahertz of 5 gig band? That's going to wipe out your spectrum. It's like, not so much, actually. Not so much. If you're careful with it and you're running a bunch of AC gear, it's actually doesn't hurt your spectrum as bad, per se. And of course, if you use the right dish, you're not going to have side lobes. It's going to be a very defined signal. You're not going to have side bleed or back bleed that's going to affect the other devices that are co-located on the tower. So it's going to perform. And it's kind of my go-to, really, for you know, long-range links that are unlicensed. But again, there is also better product out there like Cambium or Cyclus, Aragon. There's all sorts of good shit out there that you can use. So I think that's my rant this morning. Is the there's your, like, how to utilize your spectrum a little bit more efficiently. So in summary, for your point to multi-point, your last mile, try to be a little bit smarter. Don't use 3 radios, use 4. So 4 APs instead of 3. Keep an even number, because then you can channel recycle with Ubiquiti gear, or go up to Cambium and use GPS synchronization so you can tie all your radios together and save spectrum. Be smart about it. Don't be cheap. If you're going to be using those crappy Rocket ACs or radios that don't have any GPS sync at all, you're going to kill your equipment. When it comes to point-to-point links, backhauls, try to stay out of the DFS bands, you know? And because you're going to have more power and more stability, because you don't have to worry about your channels jumping, right? So keep that in mind too, right? That's something else you want to consider. Little tricks like this, using either higher frequencies like millimeter wave or actually using licensed bands, that's going to help you with your backhauls too. And ultimately what it comes down to is utilizing your spectrum in an efficient manner so that you're not killing out the neighboring incumbents, like your other companies that you're dealing with in your area, and you're providing good, reliable, consistent service to your clients. Remember, folks, after this whole COVID thing's over, many companies are going to realize that they don't have to have an office space and that people can work from home. I mean, like, people are proving right now that they're not a bunch of lazy sacks of shit, and they actually will work if they're at home. In fact, sometimes a lot better because the stress level's a lot lower. They're in a comfortable environment, unless you have kids. So, yeah, that's kind of my rant for today. And let's see how these guys go, because, you know, now that the warm weather's here in Kazakhstan, we can actually move around freely. So, you know, when I'm driving, I figure I can bring up a topic and just kind of, you know, verbally brainstorm about it for you guys so that you guys can learn a little something from my head meats. So anyway, like and subscribe below. And if you have a topic that you want me to discuss, fucking leave it in the comments and I'll take care of it for you. Oh yeah, and by the way, I'm not a monetized channel, clearly, because I swear. Adult content. It's got to be entertaining. This is the sort of shit that kids don't want to watch anyway, and you guys need a little giggle, you know, while you're listening to me. So let me make it fun. But anyway, yeah, leave your suggestions in the comments of what topics you want me to rant about, and if it's something that I don't know about, I'll research it a little bit, and of course I'll bring it to the table. But you'll never catch me talking about something I don't know about, okay? So anyway, thanks for watching, guys, and I hope that this was insightful, looking at my fat, ugly face and listening to my god-awful, screechy, shitty voice. You have a great day, and I hope you learned something. Ta-ta. And now I sit here for 10 minutes until I get to my destination, waiting for the fucking camera to turn off.